Hi, in this particular video we're going to be looking at the June 2019 higher tier Edexcel paper for GCSE Maths. Please do stop the video, have a go at each of the questions and compare your solutions. If you need any help, always add a comment below, I'll always come back to you and I look forward to seeing you inside the video. Hi, in this video we're going to be looking at the GCSE Maths paper for Edexcel, and it's the higher tier from the June 2019 series. This is the second video in the playlist. In the previous video we completed through to question number 11, so we're going to start here with question number 12 onwards. Please, as always, stop the video, have a go at the question, compare your solution. Okay, so this particular one, we've got three spheres. Okay, we've got P, Q and R, and Q is 50% more than the volume of sphere P. So let's have a look at how we can actually write that out. Well, we've got P, Q and R. So if P is a volume of, let's say, 1, then Q is going to be a volume 1.5 times bigger than that. Now, in this particular case, what I'm going to do is actually use fractions, because actually it will be a little bit easier. So the fraction equivalent of 1.5 is going to be 3/2. Okay, so in other words, this is 1.5 times, or 3/2 times bigger than the volume of P. And the volume of R is 1.5 times this volume as well. So if I multiply that by 3/2, the volume of R is going to be 9/4. So 3 times 3 is 9, and 2 times 2 is 4. Okay, so the question then says to us, find the volume of sphere P as a fraction of the volume of sphere R. Well, let's just look at it as we've got it at the moment. What we're basically saying is that, so R, which is this volume here, is equal to 9/4 times P. And then really the part of the question that they're asking for is to make P the subject of this formula. So at the moment, R is the subject. We want to change it to P. So what we need to do is divide both sides by 9/4. So if I divide R divided by 9/4 equals P. Okay, so effectively, when you divide something of a fraction, if you like, I've got R/1. Okay, and then what I would do is I would multiply and flip, and that would equal P. Okay, I don't know if you can see that at the bottom of the screen now. So sorry, that went off the screen. So what I've done is I've multiplied and I flipped over the other side, which is really just a way of writing that P equals 4/9R. Okay, and that actually is the answer to this particular question. Now, unfortunately, on this exam, these couple of questions, question number 12 and perhaps question number 13, are going to be quite tricky. It's just the way it is, I'm afraid. But they are only a couple of marks, I think, for this particular one. It's about 3 marks on this one. But hopefully you can see that from the work in here. Let's move on then to question number 13. Question number 13, we've got a slightly different challenge where we're looking at algebraic proof. What we can do is we can say, well, if we look at a number, let's just check a particular number. Let's choose the number 7. Okay, if we feed this number 7 into this formula, let's have a look and see what happens. Well, if I say, I've got then n squared minus n, so that's going to be 49 minus 7, which is going to be equal to 42. So in the case of 7, it's correct. It's not an odd number. It's actually an even number. So let's try it with another number, just so we've got a bit of completeness here. If we try it with the value of 8, I'm going to do again n squared minus n, which is 64 minus 8, and that's going to give us 56. So actually, in the case of 7 and 8, yes, that's absolutely true. It's not an odd number. But what they're asking us to do is to prove it that for all numbers greater than 1, you need to prove it's never an odd number. Okay, so in order to do that, we have to use algebra proof, which is what we're going to do here. So in algebra proofing, and again, if you have a look on my channel, you'll see that there are some playlists that have a lot of these sorts of questions. What we say is that we've got kind of three standards, if you like. We say that n is equal to any number, which means if you double it, in other words, 2n, that's equal to any even number. And if you add 1 to it, it's always going to be any odd number. And it's this principle that we're going to use when we apply these numbers, or these two numbers, into this formula. Because what we're going to say is that if we choose that we're going to use n as an even number, I'm going to use this and I'm going to put it into this expression. So what I'm going to say is, okay, when n is even, then it's going to equal 2n. And then I'm going to put it straight into the formula, n squared minus n. So that's going to be 2n squared minus 2n. Now, if I expand that, I'm going to get 4n squared minus 2n. And it means then I can factorize this for 2, which means I get 2n squared minus n. So because 2 is a factor, it must be even. Okay. Hopefully that's all right for you. That sort of principle is very similar to the sort of principles that we use when we're doing lots of other algebra type proofs. So we've used that n is an even number. What happens when n is an odd number, which is 2n plus 1? So in other words, now we're using a number like 7 or 13 or whatever it might be. So let's have a look at that. So when n is odd, we're going to equal 2n plus 1. But we're going to use exactly the same formula, n squared minus n, and we're going to put 2n plus 1 in place of n. So I'm going to have 2n plus 1 squared minus 2n plus 1. Okay, right, let's have a look at what happens when we expand that. Well, if we expand this, we're going to get 2n plus 1 multiplied by 2n plus 1 minus 2n plus 1. Okay, now be very careful about this minus sign here, because this minus sign will affect these two terms in here. But let's expand this out. I'm going to get 4n squared, and then I'm going to get plus 4n plus 1 minus 2n. And remember, it's minus 2n and minus plus 1, which is minus 1. Okay, now, if we tidy all of that up and gather the like terms together, what I end up with is 4n squared on its own, plus 4n minus 2n is going to be plus 2n, and plus 1 minus 1 is going to go. So I'm going to lose those. So again, I can factorize this for 2, and I get 2n squared plus n. Okay, and again, if 2 is a factor, it must be an even number. Okay, so really quite a tricky question, I think. Certainly for 2 marks, quite a difficult question to work through, but that's certainly the way I would do it, at least, because really you've got to prove it that it's never an odd number. In other words, it's always going to be an even number regardless of what you do. I hope that's been helpful for you. If you're not sure, add a comment below and I'll put the link through for the playlist for algebra proof on this one. Okay, let's have a look at number 14 then. So find the exact value of tan 30 times sine 60. Well, there's a couple of different options here. You can either remember them, okay, you can remember these values, or what might be useful is we need to bear in mind this is a non-calculator paper. So one of the useful things is to remember this little triangle. Now, I've not drawn this particularly well, but hopefully you'll get the idea. It's a right angle triangle with 30 degrees here, 60 degrees here, and this is a unit length of 1, this is a unit length of 2, and this is a unit length of root 3. Now, if you remember that, that will give you the ability then to find the different values, because basically we can then use SOH, CAH, TOA. So SOH, Krakatoa. All right, so what we're looking at first is the tan value for 30 degrees. So here's my 30 degrees. If you remember, tan is opposite, which is this length, divided by adjacent, which is this length here. So opposite over adjacent. So the tan of 30 degrees is going to equal opposite 1 divided by root 3. Okay, let's have a look then at the sine of 60 degrees. So the sine of 60 degrees is the opposite divided by the hypotenuse. Okay, so in this particular case then, I've got the opposite of 60 degrees is going to be root 3. Remember, it's opposite the angle. Okay, so this adjacent has now become the opposite. Okay, so sine of 60 degrees, the opposite is going to be root 3, and then the hypotenuse is going to be 2. Okay, and that's it. So really now it's just a case of solving this. Well, actually, we can divide both top and bottom by root 3. We can cancel these two out. So we end up with 1 times root 3 divided by root 3 times 2. That will cancel out, or those two will cancel out. And the answer to this one will actually be a half. And that would be the end of that particular question. Okay, so again, if you're not sure, please do add a comment below. I'll come back to you and I will post you through a link on some other videos that might be useful. Okay, let's move on then to question number 15. So in question number 15, we have a hemisphere and a cone that's been put together. And we're told that the total shape is k pi centimeters cubed, where k is an integer. So really all they want us to do is work out the volume, because the volume actually is going to be k times pi. That's it, really. So when it says work out the value of k, don't get too sort of phased by these things. It's all about this is just a whole number. Okay, so let's divide this up into two separate pieces. The first thing I'm going to look at is going to be the volume of the cone. Okay, well, the volume of the cone, we've very helpfully been given a third pi r squared h. Well, h is going to be 10, and the radius of this cone is going to be 3. It's half the diameter. Okay, so we can put that directly into the formula, and I will try to kind of not move this piece of paper around too much, but let's have a look at the cone. Okay, so the formula for the cone is a third pi r squared h, and that's going to give us a third times pi times, in this particular case, the radius, as I mentioned, is 3 squared, and h is going to be 10, which is the vertical height of the cone. Okay, so 3 squared is 9. 9 times 10 is 90, and a third of 90 is going to be 30. So this will give you 30 pi, and that would be the answer to the volume of the cone in terms of pi. So let's have a look now at the volume of the hemisphere, which is this one at the bottom here. Now remember that it's a hemisphere, it's half of this. So what we've got to do is use this formula, but we multiply it by a half. So the hemisphere, okay, is going to be a half multiplied by 4 over 3 pi r cubed. Okay, and you'll notice I've used brackets on there just to kind of differentiate it a little bit. So let's have a look at how that works. So I've got a half times 4 over 3 times pi, and the radius again is 3, but this time it's going to be 3 cubed. Okay, so a half times 4 over 3 times pi, and 3 cubed is going to be 27. Okay, so let's look at what goes on inside the brackets, just the calculation itself. So 3 into 27 is 9, and 9 times 4 is 36. So it becomes a half of 36 pi, which is going to be 18 pi. And that's the volume of the hemisphere. Okay, so therefore, to answer that particular question, we're looking at the total, which is going to be the cone, which is 30 pi, plus the hemisphere, which is 18 pi, which is going to be 48 pi. Okay, so therefore K, I'll just put it this side, K equals 48, and that's the answer to that particular question. So it's just one of those ways of asking what's the volume of this particular 3D shape. Okay, so we're going to do one or two more questions just to finish this particular video. Shouldn't take very long now, so we're on 14 minutes. Let's have a look then at question number 16, which is a counting strategies type video. Again, it's one of those where actually there's a lot of detail here, but it doesn't really need too much work on it. Okay, so we've got a choice of 5 numbers for each of these little dials here. So the number of different 3-digit combinations that can be set for the combination lock is going to be 5 multiplied by 5 multiplied by 5, which is 125. That actually is the answer to that particular question. Okay, let's have a look at part B. It says, if I leave that at the top there, it says, how many of the possible 3-digit numbers have 3 different digits? Well, okay, so we've got 125 of them that would have a choice of any one of the 5. Part B is saying, well, actually, we can't duplicate any of the numbers. So therefore, it's just going to start with 5, but then the next one, we've only got a choice of 4, and then the next dial, we've only got a choice of 3. So that's going to give us 60. So actually there are 60 different combinations where we don't duplicate the numbers. Okay, so let's move on then to question number 17. And question number 17 is one of those which, again, it looks a little bit trickier, but just the way we kind of work through these sorts of things is recognizing that this really is a fraction and it's equal to another fraction, or rather we can write this in a slightly different way. So we can write this as x squared over 1 is equal to 3x plus 5 over 2. And this is just a technique that you can use to be able to work these sorts of things out. So what we're doing is we're saying x squared over 1 is equal to 3x plus 5 over 2. Okay, so it's then a case really of just solving for x, finding the value of x, and you'll spot that it is an x squared term, so therefore you'll need to be able to factorize this. So let's firstly cross multiply, and again this is a technique I use quite a lot in a lot of my videos. I cross multiply just to make my whole life a little bit easier. I can write this as 2x squared equals 1 times 3x plus 5 is 3x plus 5. Okay, now when we're going to factorize, we need to make it equal to 0. So if I bring these two terms over, I'm going to get 2x squared, beg your pardon, minus 3x minus 5 equals 0. And then really it's a matter of factorizing that for x. So the way I'll do that is I'll say 2 times minus 5 is going to be minus 10. Now what two numbers, when I multiply them together, make minus 10, and when I add them together make minus 3? Well, those two numbers are going to be minus 5 and plus 2, because if I add them together I get minus 3. If I multiply them together I get minus 10. So I can write this again in a slightly different format as 2x squared plus 2x minus 5x minus 5 equals 0. Now I haven't changed its value. What I've done is I've just changed the way I've written it, okay, because plus 2x minus 5x is still minus 3x. But what it does allow me to do is to factorize these two terms and then factorize these two terms and look for a common factor. So what I'm going to do is look at these two terms and factorize them for 2x. And that means I get x plus 1. If I factorize these two terms for minus 5, guess what? I also get x plus 1 equals 0. So this is a technique that I've used a lot. And again, if you're not sure, let me know. There is a playlist on the channel that I can put in the comments for you. Okay, so because I've got this common factor, I can bring all of this together and rewrite it. It's 2x minus 5 times x plus 1, and that equals 0. So now, at long last, I've got my two values of x. My first value of x is going to be, if I sort of put my thumb over there, 2x minus 5 equals 0. So if I bring this 5 over, I've got 2x equals 5. So x must equal 5 over 2, or if you prefer, 2.5. Okay. Similarly with this one, x plus 1 equals 0. So therefore, x equals minus 1. And those are the two values, okay, for solving this particular equation. So therefore, x equals 5 over 2, or x equals minus 1, and that would be the answer to this question. Okay, I hope that's been useful to you. I think we're about 20 minutes into the video, so I'm just going to do one final question, I think, which is question number 18, and then that will give us a reasonably good finish on this particular video at about 25 minutes. Okay, so question number 18 deals with surds, really. So we've got a couple of questions, 18a and 18b. So 18a is root 3 plus root 12 in the form. Okay, so all we've got to recognise is that we can't change root 3, but actually we can write root 12 as root 4 times root 3. Okay, so because 4 times 3 is 12. So the square root of 4 is 2. So I can rewrite that as root 3 plus 2 root 3, which is in total 3 root 3, and that's the answer to that particular question, 3 root 3. Okay, let's have a look then at part B, and it says express 1 over root 3 to the power of 7. Okay, all right, so there's quite a lot of playing around with this particular one, but basically what I'm going to do first is I'm going to rationalize the denominator. In other words, I'm going to make the bottom number a whole number. So what I'm going to do is I'm going to say, well, that's the same as saying 1 over root 3. And if I multiply top and bottom by root 3, what I'm going to get is going to be root 3 at the top, and then root 3 times root 3 is root 9, so it's going to be 3 at the bottom, and all of that to the power of 7. Okay, so all I've done is I've just made it so the bottom number is a whole number. It's the equivalent fraction because I've multiplied top and bottom by root 3. It just makes my life a little bit easier to do that. Because if I've got everything to the power of 7, effectively what I've got along the top is going to be, and this is the point in the video where I'm going to have to do quite a bit of very fast writing. Okay, it's going to be 5, 6, 7, and all of that is divided by 3 to the power of 7. Now, the reason I've done it that way is because for every group of 2 together, that is the same as saying root 9, which is also the same as saying 3. It's exactly the same as what we did here. So actually, I end up with crossing all of those out. I've got 1 lot of 3, 2 lots of 3, and 3 lots of 3. So I can write that as 3 cubed, and then I've got 1 root 3 left, and that's divided by 3 to the power of 7. Okay, so it's a neat little trick just to kind of make sure that you're dealing with numbers that make it just a little bit easier for you. Okay, so we're dividing now by 3 root 3 divided by 3 to the power of 7. Okay, so that's actually going to be the same as, say, if I write it over here, root 3, and I'm going to put 3 to the power of 4 at the bottom, 3 to the power of 4, because 3 take away 7 is going to be 4. All right, now because it's at the bottom there, if I wrote this at the top, it would be 3 to the power of minus 4. Okay, but because it's in the denominator, I can still write it as a positive number. Okay, if I then multiply 3 to the power of 4 out, it basically means 3 times 3 times 3 times 3. Okay, I haven't shown the calculation on this. It is a non-calculator, but you would need to calculate that. So at the top, I'm going to get root 3. At the bottom, I'm going to get 81. 1, and that's actually the answer to this particular question. Okay, I hope that's been okay for you. It did take a little bit of working out. There are some quite good questions, quite challenging questions in this particular paper. I hope you found it useful. Please do add a comment below if you're not sure about anything. I'll always come back to you. And I'll look forward to seeing you in the next video where we're going to start from question number 19 onwards.